So let's try to understand a harmonic progression or a harmonic sequence. It is a sequence of number in which the reciprocal of the terms are in arithmetic progression. Meaning, let's say we have a sequence of non-zero numbers a1, a2, a3, and let's say these numbers are in harmonic progression, provided if we take the reciprocal of each term. So the first term, which is a1, its reciprocal will be 1 over a1. Then the reciprocal of the second term, a2, will be 1 over a2. So when you form the new sequence, if the new sequence is an arithmetic progression, then we immediately say that a1, a2, a3, all the way up to the nth term, these are going to form a harmonic progression. For example, let us consider the three numbers half, 1/4 and 1/6. So these three numbers are in harmonic progression. That's because if we take the reciprocal of each terms, so the first term the reciprocal is 2, the second term has a reciprocal of 4, and the third term has a reciprocal of 6, immediately we see the 2, 4 and 6 are going to form an arithmetic progression. That means it is going to have a common difference of 2. So since these three numbers are in reciprocal, so that means the reciprocal are going to be in harmonic progression. Let's try to understand harmonic progression with the help of few problems. So here we need to verify that the sequence given by 1, 1/4, 1/7, 1/10 is a harmonic progression. So let us begin. So here let's consider the first term a1. So a1 is 1. So its reciprocal, which is a over 1 over a1, so that's going to be 1 as well. Then we consider the second term, which is a2, so it is 1/4, and its reciprocal 1 over a2, so let this be 4. Then we have a3, the third term, that's 1 over 7, which means its reciprocal 1 over a3, it's going to be 7. And similarly the fourth term, which is 1 over 10, its reciprocal 1 over a4 is going to be 10. Now clearly we can see here that let's call 1 over a1, let's call it a1 prime, 1 over a2 as a2 prime, then we have 1 over a3 as a3 prime, and 1 over a4 as a4 prime. So clearly we can say that a1 prime, a2 prime, a3 prime and a4 prime forms a arithmetic progression. This can continue, meaning we have, well, the first term is 1, 4, 7, 10. So these sequence are going to form an arithmetic progression because clearly we have a common difference of 3. If this is going to form an arithmetic progression, then we can say that the reciprocal of each of these terms, so reciprocal of 1, which is nothing but 1, then you can say reciprocal of the first term 1, the reciprocal of the second term 1/4, reciprocal of the third term 1/7, reciprocal of the fourth term 1/10. These sequence are going to be in harmonic progression. So this is how we can show that a given sequence is going to be harmonic progression if we can show that the reciprocal of each terms are in arithmetic progression. So now that we have now that we have verified that the sequence is a harmonic progression, so we'll need to find out the 10th term. So to begin with, what we'll do, we'll not try to find out the 10th term from the HP or the harmonic progression. We will use the arithmetic progression, which is 1, 4, 7, 10. So these sequence are in arithmetic progression. Now clearly from here we can find out the 10th term. So here let's first state the first term and the common difference. So our first term is going to be 1. The common difference is going to be 4 minus 1, so that's going to be 3. Now how do we find out the 10th term? So that's given by the formula a plus 10 minus 1 times d. So this will be equals to, so our first term is 1, 10 minus 1, so that's 9. 9 times d, so d is 3. So when 9 times 3 is 27, 27 plus 1 is 28. So this is in fact actually a prime 10. This is the 10th term of the arithmetic progression. If this is the 10th term of the arithmetic progression, then the 10th term, we can say 10th term of the harmonic progression, so that's going to be the reciprocal of the 10th term of the arithmetic progression. So 10th term of the harmonic progression will be, all we have to do is take the reciprocal, so that's 1 over 28. So this is going to be the 10th term. So let's try to do another problem in order to understand the harmonic progression. Problem number 2. We need to verify that the given sequence is a harmonic progression, and after that we'll have to find out its 8th and the nth term. So let us begin. Now we have here the first term. So let's note down the first term. So that's a1, which is 1 over 6. Then we have the second term, that's 3 over 16. Then we have the third term, that's 3 over 14. we have our fourth term, that's 1 over 4 and so on. What we'll do, we'll take the reciprocal. So we'll first take out a1 prime. So a1 prime is nothing but the reciprocal of the first term. So that's going to be 6. Similarly, we have a2 prime, which is the reciprocal of the second term. So we have 16 over 3. Then we have a3 prime. So that's the reciprocal of a3. That's 14 over 3. And a4 prime will be the reciprocal of the fourth term. So that's 4. First, let's show that 6, 16 over 3, 14 over 3, 4 are in arithmetic progression. That's because if we take this second term, 16 over 3, and from it subtract the first term, so this is going to give us negative 2 over 3. Similarly, this common difference, which is negative 2 over 3, is also equals to, if we take the third term, 14 over 3, and from it, if we subtract the second term, which is 16 over 3, we still get the same common difference. And this equally holds true for taking the fourth term and from it subtracting the third term, we still get negative 2 over 3. So this is going to be the common difference. So we can say that 6, 16 over 3, 14 over 3, 4 are indeed in arithmetic progression. Now, because it's an arithmetic progression, we can find out its nth term. The nth term is given by the formula, the first term plus n minus 1 times the common difference, d. Fine. So what's the first term here? So the first term is simply 6. So this is going to be the first term. Then this is going to be the common difference, which is negative 2 over 3. We're going to substitute this value. So we have 6 added to n minus 1 times d. So d is negative 2 over 3. Let's simplify this. We get 6 minus 2n over 3 plus 2 over 3. So that's going to give us 20 over 3. So we're going to add 6 with 2 thirds. So we get 20 over 3 minus 2n over 3. So let's take positive 1/3 as the common factor. So we're 1/3 multiplied to 20 minus 2n. So this is the nth term of the arithmetic progression, not the harmonic progression. So if we want to find out the nth term of the harmonic progression, the nth term of the harmonic progression will be nothing but the reciprocal of an. So that's nothing but 3 divided by 20 minus 2n. All we have done is taken the reciprocal of this 1/3 times 20 minus 2n. So this is the nth term. Now that we have the nth term, we will try to find out the 8th term. So all we have to do is replace the value of n with 8. So 8th term of the harmonic progression will be 1 over a8. So that's the 8th term. So this is simply given by 3 divided by 20 minus 2 times 8. So let's solve this. We get 20 minus 16. So 20 minus 16 is 4. So 3, 4. So this is going to be the 8th term of the harmonic progression, not the arithmetic progression. The nth term is going to be given by 3 over 20 minus 2n. Fine. So let's go to the third problem. Problem number 3. So here the 8th term of a harmonic progression is given, that's half, and the 14th term is also given, so it has a value of 1/3. We need to find out the general term as well as the 20th term of the given harmonic progression. Let us begin. So first we will state the first term and the common difference. So let the first term be and the common difference of an arithmetic progression. So we're going to start with an arithmetic progression b, a and d respectively. So a is the first term and d is going to be a common difference. So it's given here that the 8th term of the HP, it's given there, we have a harmonic progression, its 8th term is given as half. This means that the 8th term of the AP, that's nothing but the reciprocal. So this will have to take the reciprocal of half, so that's going to be simply 2. Now we know that the 8th term of an AP, so that's given by the formula a plus 8 minus 1 times d equals to 2. So we have a plus 7d equals to 2. So that gives us the first equation. Next, it's given here that the 14th term of the harmonic progression. So we have to be very careful what we have been provided with. It's given that the 14th term of the harmonic progression is 1/3, which would mean that the 14th term of the arithmetic progression, that's going to be the reciprocal of 1/3, which is simply 3. Now what's the 14th term of the AP? So that's given by a plus 14 minus 1 times the common difference d equals to 3. and that gives us the next equation, a plus 13d equals to 3. So this is equation number 2. So we have two unknowns, a and d, and we have two equations. So let's solve equation 1 and equation 2 to obtain the value of a as well as d. So what we'll do, we'll take equation number 2, and from it we're going to subtract equation number 1. So we have a plus 13d equals to 3, and from it we're subtracting a plus 7d equals to 2. So let's perform the subtraction. So a and a gets cancelled out, 13d minus 7d, so that's going to be 6d. Equals to 3 minus 2, so that's going to be 1. So solving for d, we have d equals to 1/6. We have the value of the common difference d. Now let's try to find out the value of a by using either equation 1 or equation 2. So we're going to use equation number 1. So from equation number 1, we have a plus 7 times d. So d is 1/6. We have 7 over 6 equals to 2. So a will be equals to 2 minus 7 over 6. So a is equals to 12 minus 7 over 6, which is simply 5 over 6. So now we have the common difference as well as the first term. So we can define the nth term of the AP. So let's do that. So the nth term of the arithmetic progression, which is given by the formula a plus n minus 1 times the common difference d. So that will become 5 over 6 added to n minus 1 times the common difference d. Let's further simplify it. So we have 5 over 6 plus n over 6 minus 1 over 6. So 5 over 6 minus 1 over 6, that's going to be 4 over 6 added to n over 6. If we take 1/6 as the common factor, so this is get multiplied to 4 plus n. So this is the nth term of the AP. Then what is going to be the nth term or the general term of the harmonic progression? All we have to do is take the reciprocal of the nth term of AP. So we will get 6 divided by 4 plus n. So this is going to be the nth term of the given harmonic progression. And now we need to find out the 20th term as well. So the 20th term is let's find it out. So the 20th term of the harmonic progression, so that's simply we are going to replace the value of n with 20. So we have 6 divided by 4 plus 20, which is 6 over 24. When we know the 6 times 4 is 24, so we get 1/4. So this is going to be the 20th term of the harmonic progression, and its nth term is given by 6 over 4 plus n. Now let's go to the next problem. Problem number 4. There's a particular term of the HP, the harmonic progression, whose value is 1 over 102. Let us begin. So here, let's say that instead of considering the sequence in HP, we'll consider the sequence to be in arithmetic progression. All we have to do is take the reciprocal of each terms. So let 2, 7, 12 are in arithmetic progression such that we can find out the last term. So here the nth term, let it be 102. Fine. So that's the last term. Now we know that the nth term is given by a plus n minus 1 times d. So that's going to help us find out the value of n. So what is the nth term? So that's 102. This will be equals to the first term plus n minus 1 times. We'll also have to find out the common difference. So the common difference is 7 minus 2. So that's going to be 5. We have 5. We have 102 minus 2 equals to n minus 1 times 5. So we get 100 equals to n minus 1 times 5. So n minus 1 will be 100 divided by 5. So that's 20, which gives us the n value is 21. Now this n value, we don't have to worry about it. We don't have to take any reciprocal way. So this the number of terms is going to be the same for the HP as well. So that means, therefore, we can say the 21st term of the HP or the harmonic progression, 1/2, 1/7, 1/12, that's going to be 1 over 102. Fine. Let's go to one more problem. Problem number 5. So here we're given the 20th term of an arithmetic of a harmonic progression. So that's 1, and the 30th term is -1 over 17. We'll need to determine the largest term. So let's try to do the problem in a slightly different way. So we'll first begin by considering let A and D be the first term and the common difference of a arithmetic progression. So we'll start out with an arithmetic progression. So here a and d represents the first term and the common difference. Then what will be the 20th term of the HP? So the 20th term of the HP is going to be 1 divided by, since we'll have to take the reciprocal of the 20th term of the arithmetic progression, so that's simply a plus 20 minus 1 times the common difference d. So it's given here that the 20th term is 1, so we have 1 equals to 1 over a plus 19d, or we simply get a plus 19d equals to 1. So let this be equation number 1. And it's also given that the 30th term of the HP, the 30th term of the harmonic progression, that's given by 1 over, that's the reciprocal of the 30th term of the AP, or the arithmetic progression. So we have a plus 29d. So it's given that the 30th term is negative 1 over 17. So this will be equals to 1 over a plus 29d, or what you can do, we can take the reciprocal on both sides and rewrite the equation as a plus 29d equals to negative 17. So let this be number 2. The next task will be to find out the value of a and d, because we have two unknowns and two equations. So let's do one thing. Let's take equation number 2, and from it let's subtract equation number 1. So 2 is a plus 29d equals to negative 17, and a is equation number 1 is a plus 19d equals to positive 1. Fine. So what we'll do, we'll subtract them. So a minus a, that goes away. 29d minus 19d, so that's going to be 10d. 10d is going to be negative 17 minus 1, so that's negative 18. So d value comes out to be negative 18 over 10, or simply d is equal to negative 9 over 5. Now that we have the value of the common difference d, so let's use equation number, we can use either 1 or 2. So I'm going to use equation number 1 to find out the value of a. So we have a plus 19 times negative 9 over 5 equals to positive 1. So a will be equals to, so 9 times 19, that will be 171 over 5 added to 1, or simply a is 176 over 5. Now that's going to be the first term, and we have the common difference d, but this is for the arithmetic progression. A and d represents the first term and the common difference of the arithmetic progression. We have already specified it. Now what we have to do is we have to determine the largest term. So let's do one thing. Let us suppose that let the nth term, let a n be the largest term. This is an assumption. So if it is the largest term, then how do we find out the largest term? So the nth term, this is the largest term of, we are obviously have to find out the largest term of the given harmonic progression. So the nth term, which is given by 1 over a plus n minus 1 times the common difference d. Fine. So this will be equals to 1 over, in place of a, we have 176 over 5 added to n minus 1 times the common difference. So that's negative 9 over 5. Let's further simplify this. We are going to get, well, let's multiply both numerator and the denominator with 5. So we have 5 divided by 176 minus 9n plus 9, which means we have 5 divided by 185 minus 9n. So this is the nth term of the harmonic progression, which is given by 5 over 185 minus 9n. Now in order to make the nth term as large as possible, the denominator has to be as small as possible. So 185 minus 9n, this will be small for n value equals to 20. So if we take n equals to 20, then we have an given by 5 over 185 minus 9 times 20. So that's going to be 5 over 5, which is going to be 1. So that means this is the highest possible value for n equals to 20. So that means the 20th term is going to give us the highest value of the given harmonic progression. So the 20th term, which has a value of 1, that is the largest term of the given harmonic progression. So this is how we can use harmonic progression to solve a problem.